What are paired t-tests? When should we perform a paired t-test? And how to perform a paired t-test? In this video, we will try to understand that. Let's say a teacher wants to determine whether the difficulty level of two tests on the same subject is the same. So, the teacher conducted the tests on 20 students on 2 consecutive days, and she measured the differences in the marks obtained on 2 tests by the same students. Let's say here is the result of the 2 tests. Now, the question is, can we say from this data that the difficulty level of the 2 tests is significantly different? To determine that, we can perform a paired t-test. A paired t-test is a hypothesis test that can be used to test whether the mean difference between pairs of measurements is 0 or not. In this case, the paired t-test can test whether the mean difference between the marks obtained in the 2 tests is 0 or not. If the true mean difference is 0, that will mean the difficulty level of the 2 tests is the same. And if the true mean difference is not 0, that will mean the difficulty level of the 2 tests is not the same. Please note that there are a number of assumptions for a paired t-test. They are: the observations should be independent of each other. The distribution of the differences should be approximately normal distribution, and each paired measurement should be obtained from the same subject. For example, in our example, each student should appear in both the tests. So, let's look back at our example. We can state our hypothesis now. The null hypothesis will be that the true mean difference between the marks obtained is 0. In other words, mu d is equal to 0. And the alternative hypothesis will be that the true mean difference between the marks obtained is not 0. In other words, mu d is not equal to 0. Please note that the sample mean difference is the point estimate of mu d. So, we will perform a two-tailed hypothesis test. Let's also assume that the significance level is 0.05. So, given the differences in test scores, we will first calculate the t-statistic or t-score. The formula for calculating the t-statistic for a paired t-test is the following. If di is the difference between the marks obtained by the ith student, n is the sample size, d bar is the mean of the differences, sd the sample standard deviation of the differences, and t is the test statistic for the paired t-test, then d bar is equal to summation from I is equal to 1 to n di by n. Sd is equal to root over summation from I is equal to 1 to n di minus d bar whole square divided by n minus 1. And t is equal to d bar minus mu d divided by sd by root n. In our example, mu d is equal to 0. So, d bar is equal to 1.45 after calculation. Sd is equal to 5.04 after calculation. And t is equal to 1.29 after calculation. Now, we will look at the t-table to find out the critical value. In our case, the degrees of freedom is equal to the sample size minus 1 is equal to 19. Here is the t-table. We will look at the row for degrees of freedom is equal to 19 and the column for the significance level of 0.05 for the two-tailed test. We get the critical value to be 2.093. The absolute value of our t-score is 1.29 and that is less than the critical value which is 2.093. So, the t-statistic falls within the acceptance region. Hence, we fail to reject the null hypothesis. Therefore, we can conclude that there is no significant difference between the difficulty level of the two tests. I hope this helps. Interested viewers who want to know more, please visit the website of the security body or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.